To understand what is no tension condition, first we'll have to revise the concept from stress distribution of base or stress distribution at base. So in the previous video of stress distribution at base, we have seen three conditions or three cases. In the first case, sigma 0 was greater than sigma b. That means the direct stress was greater than bending stress. So in this case, we have seen that both the maximum and minimum stresses at the base are positive. Similarly, in case 2 also, both were positive. However, in the case 3, when the bending stress was greater than the direct stress, the minimum stresses, it was coming as less than 0. That means tensile stresses were developing. So we have to design in such a way that these tensile stresses are not developed in our member. That means there should be no tensile stresses. And this condition which produces no tensile stresses is called as no tension condition. Okay, the condition which generates no tensile stresses is called as no tension condition. We have also seen in the previous class that concrete is weak in tension if the tension or if the tensile stresses are produced, then there will be tensile cracks which will develop in the concrete. So to avoid this, we will be using the no tension condition. That means we will be using the case number 1 and case number 2. We will neglect this case number 3. So if we combine these two conditions, that is direct stress is greater than bending stress and direct stress is equal to bending stress, we will get the condition that is direct stress is greater than or equal to bending stress. This condition is called as no tension condition. Okay, so here we can write no tension condition is direct stress is greater than or equal to bending stress. So we'll write some points here. Direct stress should be greater than or equal to bending stress. Direct stress should be greater than or equal to bending stress. Concrete is strong in compression and weak in tension. Okay, as most of the members are made up of concrete. While designing the no tension condition, should be followed. So we should follow the no tension condition. If we do not follow, then what will happen? That means if the tension develops in concrete member, then what will happen? Tensile cracks will develop. So the tensile cracks will develop. Now we will be deriving one equation here. We know the main condition is sigma 0 is greater than or equal to sigma b. but sigma 0 is equal to P by A and sigma B is equal to M by Z. This M is PE by Z. Substituting here, sigma 0 greater than or equal to sigma B. Sigma 0 is P divided by A. Sigma B we can write it as PE by Z. So this P will get cancelled. So it is 1 by A greater than or equal to E by Z. So we can write it E is less than or equal to Z by A. So this condition is important now. This condition tells us that the eccentricity should be less than or equal to section modulus divided by area of cross section. Okay, this E stands for eccentricity. That means the location of load. So now in the next class, we will be seeing what should be the eccentricity for rectangular section and what should be eccentricity for circular section.